Hi guys, so in this video we're going to continue with our homologa series. So we're taking it further. So these are going to be the last homologa series that we're going to take. It's aldehydes, ketones, alcohol, and carboxylic acid. So after knowing this, and then we're going to move on to the reactions, and then we're also going to treat past papers. Okay, so here we're going to take a look at the aldehydes and ketones first. So aldehydes and ketones, these are compounds that contain the RO functional group. So RO, from now onwards we're going to use this R as a functional group, a carbon. So this kind of functional group is called the carbonyl functional group. So this kind of functional group, the functional group that consists of carbon and oxygen, carbonyl functional group, or it can be hydrogen here, or can be. So let me just remove this now. This is called the, it's a kind of functional group I'm talking about. It's called carbonyl. Please, they can ask you the functional group name, or sometimes they can ask you the functional group structure. So take note that this is a structure, of ketones and aldehydes, and the other one, this is a name of the functional group. The name. Okay, in aldehydes, the functional group is always at the end of the parent chain. So it's not necessarily at the end. It can be at start. It depends on how you count, but it doesn't matter, because you, according to the rules of this, you must start where you see the functional group. So this, the difference between the aldehydes and ketones is because for aldehydes, this thing is going to be at the end, or is going to be at a starting point, always the functional group. So that's why, and for the ketones, it's going to be in between. So that's why I wrote this R. So for aldehydes, the reason is this is because a carbon, right, and then H is this, and then this is hydrogen. So, or hydrogen or something like that. So this is what the functional group structure of aldehyde. This is a functional group structure of aldehyde. So this is going to be a structure of aldehyde, aldehyde. So, and the structure of a ketone. In the ketones, the functional group is always at the carbon that is at the carbon must not be at the end. So the carbon, that means if you have a carbon, and also there you must have a carbon. You see here you have a triple R. So I forgot to put O in between here. You must have O at some point. So this is going to be the functional group structure of ketones. The carbon must always be at the middle. So if it's in the middle, that means it tells you that there are some of the compounds that we don't have them. Remember that when we used our name, we said that if you have a 2 carbons, it's eth, and then if you have a and if you have 1, it's going to be which is meth, and if you have 2, it's going to be eth. This is 2 carbon 1, and if you have a 3, it's going to be prop. Okay, so remember that here for the starting point, by functional group only of a ketone, you must have at least 3 carbons in order to get a ketone. So that means a ketone doesn't have a meth, and it doesn't have a eth. So we have nothing, we have no compound that belongs to a ketone with eth, or is going to start with meth. We're starting at going above. Why? Because at least it must contain 3 carbons. So if you already skip meth and eth. Okay, hope you get it. So the prefix, no, not the prefix, the suffix. The suffix of ketone is on, and the suffix of R. So that means anything that belongs to a ketone is going to end with on, and is going to end with R. So let's take a look at these two things. So we said that the suffix And remember the prefix, I'm not going to go I did them in my first video, the prefix, all of for ketone is going to be on for ketone. And let's write this anal for aldehyde. And I know that I wrote al for the previous one, but let's write this one anal for aldehyde and on for ketone. All right, so we said that for the ketone, the functional group, where is it? It's always at a starting point or at the end. It depends on how you want to specify it. So let's have something like this. Okay, so here's going to be this, and here we're going to have H. So it's an example of what? It's an example of what? Of a ketone. And if they can say name this, oh sorry, of aldehyde. I was missing these things. This is an example of aldehyde. The aldehyde, the functional group, is always at the end or at the starting point. The aldehyde. So the functional group is always at the starting point or at the end. Depends on how you want to specify it. So let's name this. So since it belongs to aldehyde, it must end with anal, and since it has two carbons, it's going to start with eth. Okay, so if it belongs to aldehyde, it's going to be ethanol, right? So you don't specify where's the functional group, where's the functional group, like where's that functional group is located, the location of the functional group. Why? Because it's always in that position, it will never shift. So can you give me the structure of this, of propanol? Give me a structure of propanol. Please feel free to pause the video and try that. Okay, so it's going to be 1, 2, 3, and then you have this and you have this. This is going to be the structure of propanol, and so on. So it's easy. Draw the structure, to name it, everything. Can you name this please for me? Name this please. So this is going to be butanol. Why? Because we have 1, 2, 3, 4, and it belongs to aldehyde. The reason we say that, here the functional group is always at the end. It's always at the end. Okay, so now let's move on to ketones. So ketone is the same thing as this one, but the functional group now is at the middle. So let's just ketone. You just remove this thing here to the middle. Take it to this one here. So it's going to be, if we take it to, it's going to be C. We're taking it to here. Another C, another C. Okay, so this is the structure of a ketone. So to name this, now it's where we're using the rules of naming, because the functional group can change the position. So you start from the side that is close to the functional group, which is the side 1, 4. Okay, so the functional group is in carbon number 2, then 2, 3, 4. So it's going to be but 2 on. It's but 2 on. It's but 2 on. Because it's here, it's in the second carbon, so it's but2O. So please, can you change this to here, to this, change this, make this a ketone now. What's an aldehyde? Make it a ketone and name it. Just do that for yourself, for the sake of practicing and understanding these things. So I will do that. So here it is, and the name of this is going to be 1, 2, 3. So you have 3. It's going to be prop 2 on. All right. So I hope you are getting the idea of naming the aldehydes and ketones. So let's move on to alcohols. So alcohols, these are the organic chemistry carbons that have the functional group name hydroxyl. So the functional group name of alcohol is hydroxyl and is given by this OH, hydroxyl. So that means, and the prefix for this, the prefix, we are still using our prefix that we are always using of meth, eth, prop, and so on. Right, and this is going to be a prefix, and the suffix we are going to use all. This is going to be our suffix. Is going to be our suffix. So that means each and every compound that belongs to alcohol is going to end with all, and the functional group structure is going to be OH. So it's always like that. It's always like that, OH, and this is connected to ROH. Okay, so let's see where it's located, and don't confuse it with this one. Don't confuse it with this one. This was for ketone. This one, yeah, I mean this one. You don't confuse it with that. That's for aldehydes, and for ketones, it's going to be now for alcohol is this one. Okay, so now we know the functional group name, we know the functional group structure, we know the suffix, we know the prefix. Okay, so let's just try to give a draw a structure of this one, of ethanol. So we said that the prefix is going to be this ones here, and the suffix are going to be these ones here. So once you see something like this, ethanol, that tells you that this it's an example of alcohol. So let's give a ethanol example. We're going to give a structure of ethanol. So obviously we have 2 carbons because it's eth belongs to here 2, and this is 3, and so on. So we must have something like this. We must have something like that. This is an example of alcohol. So we call this an ethanol. Why? Because of this here. So this is a functional group of alcohol. This here is a functional group of alcohol. So this is what we're going to call alcohol. So please give the name of this one. So when you are naming here, we always indicate the position of functional group. Position of functional group. Functional group. So we indicated. The reason we didn't indicate here, can somebody tell me why we didn't indicate here? We didn't indicate here because it doesn't make a difference. You put it here, it's going to be 1. It's going to be ethanol, ethan 1 all. You put it here, it's going to be 1 all. So it doesn't make a difference. So you can just leave it, not mentioning it. But if you have something like this, now I want you to give the name for this one. I want you to give the name for this one here. Okay, so what's the name of this? Please feel free to pause the video and try. Okay, so since you start from here, it still gives the same number for this carbon. You start from here, it gives the same number for this carbon, and we must start from the side that is closest to the functional group, and both sides are. We can start here if we want to, counting the carbons. So 1, 2, 3. So since we have 3, this is going to be a propane something. Finish it. Propane 2 all. So this is a name of this alcohol. so it's easy to name them. Okay, so one last thing, give the name of this one, but 2 butane, butane 2 all. Give the name of this one, the structure, sorry, not the name. Give the structure. This is a IUPAC name. Give the structure of this one. So the structure for this one is going to be 1 2 3 4, right? So we can put our functional group somewhere. So our functional group structure is going to be here. You see, so when you start counting the carbons, start from this side because it's the side that's closest to the what is this, to the functional group. So it's going to be but2 all, butane to all. So now let's go to the different types of alcohol. So we're going to have a primary alcohol, primary, and we're going to have secondary, and the last one is tertiary. So these are the kinds of alcohol that we are going to have. So for this one, the carbon that contains the functional group is attached to one to another carbon, to one carbon. So that means if I want to give the example of this one here, the carbon that has the functional group is attached to another carbon. So actually just see R prime. I'll use R prime as a carbon that has the functional group. Is attached to one carbon. So it's going to be CrOH. So this is the carbon that has the functional group. It's attached to another carbon. Okay, so this is an example of that, because here we're going to have these, and we're going to have something like this. So this is an example of primary alcohol, because the functional group, which is this one, is attached to one carbon, which is this one carbon. So secondary, the same idea, but here the carbon that has the functional group is attached to another 2 carbons. Okay, so this is for secondary. So if it's attached to another carbon, that means it's going to be like, here you have R, and here you have R, that is R prime, that is has the functional group R prime, and then here you have this. So R prime is the R that has the functional group, and then another R. So this is a kind of a tertiary alcohol. So here that means this one must be attached to a functional group, and the rest there must be just like a normal carbons. Okay, so this is a secondary alcohol. So for the tertiary, use the same analogy. The carbon that has the functional group is attached to another 3 carbons. So this is a kind of going to do this for prime, or sorry, suppose, and do this prime is the one that has the functional group, and do this second prime, that means it's a branch, and that means it's still another one. So this is the one that has, then this is a carbon of a branch. I use double prime for that. Okay, so now when we are representing that, we're going to represent our functional group structure here, and the rest are going to be a normal carbons, tertiary alcohol. It's a kind of a tertiary. So this is going to be a branch here, this is a branch. See, so this is a tertiary alcohol. Okay, so I think you got that. Now let's move on to the carboxylic acid. So these are the kind of organic compounds that have the functional group, or the functional group name of carboxylic acid. It's called, the functional group name of carboxylic acid, it's called carboxyl group. This is a name of functional group, and is given by C, not C, sorry, it's RCOOH. This is a structure, and the way we represent that when we draw it is going to be R, and we draw C here, and we have a double bond on this side, and we have a single bond from this side. You see, so that means it's a combination of, if you take this, what is the functional group or name for that one? That one is the functional group of a carbonyl functional group. This is from carbonyl. It's carbonyl from the aldehyde and the ketones. So this is a carbonyl functional group. And when you take this is hydroxyl. So actually the carboxylic acids are just a combination of carbonyl functional group and hydroxyl functional group. So they give carboxylic acid. So here we have our so the functional group structure is given by this one. So still the prefix for this one, the prefix, we're still using the same prefix as always. It's going to be from meth, eth, prop, and so on. Prop, this is 1 carbon, 2, 3, and so on. And then the suffix for this is going to be noic acid. Each and every name that belongs to carboxylic acid is going to end with the noic acid. That's the way we see them. Okay, so can you give this one a name? So since here we're going to add double bond, we add a single bond here with hydrogen. So this is an example of a carboxylic acid. Why we're saying that? Because of this. We can see because of this. So can you give the IUPAC name for this compound? Okay, so since it has 2 carbons, it's going to be eth. And then since it has this functional group, that means it belongs to carboxylic acid, is going to end with noic acid. So this is going to be eth. It's going to be eth, and then you add this one here, ethanoic acid. See, so this is the name, ethanoic acid. See, so this is the name, ethanoic acid. So can you draw the structure of this? And again, for the carboxylic acid, we don't mention the position of the functional group because it's always at the end or at the starting point, depending on how you want to mention it. It's at the end. For me, I prefer the end. So always here, it will never change. Okay, so can you give the name, the IUPAC name of this? Propanoic acid. Can you draw the structure? Sorry, can you draw the structure of propanoic acid? So the structure of propanoic acid is going to be 1, 2, 3 on the 3rd carbon. So we're going to have our functional group, and on the 3rd carbon, so we have this. Okay, so this is propanoic acid. And now as a homework, find the name of this. Ethanoic acid. Find the structure, sorry. You have to find the structure of these, and you have to find the structure of these. Another one, to butane to all, structure of that, and find the structure of octanol. Find the structure of these things, draw the structures, and the last one is okay, draw the structure of these things as a homework. Okay, so thanks for watching my videos. I hope you are going to join me next time. when I'm doing the organic reactions.